Welcome back to the channel. Today, we're diving into one of the most important skills every technician, engineer, and problem solver needs: effective troubleshooting. Whether you're fixing a computer, repairing equipment, or solving system issues, following the right steps can save you hours of frustration and prevent mistakes. In this video, I'll walk you through a simple but powerful step-by-step guide to troubleshooting, from identifying the problem all the way to documenting your solution so you don't face the same issue twice. Stick around until the end for a bonus step that will turn you from a fixer into a true troubleshooting hero. Let's get started. Stuck with a problem you just can't fix? Don't waste hours guessing. In this video, I'll show you the exact 7 steps to troubleshoot anything, plus a bonus step that will make sure the problem never comes back. Let's jump in.
At first glance, it might seem like troubleshooting is simply fixing things when they break, but it's actually a structured process, one that, if applied correctly, can save a lot of time, money, and frustration. The aim of our session is to understand not just what troubleshooting is, but how to approach it systematically so that we can solve problems efficiently and consistently. When we think about troubleshooting, it helps to ask, when does it really happen? Sometimes, it's obvious, when something fails completely. For example, a machine or system might stop working altogether, bringing operations to a standstill. This is critical because downtime can be incredibly expensive. In industries like manufacturing or it, every minute of unplanned downtime can cost thousands, sometimes hundreds of thousands of dollars. Having a skilled team that knows how to troubleshoot under pressure can make the difference between a short pause and a major crisis. But troubleshooting isn't only about emergencies. Sometimes, a machine or system is technically still running, but there are warning signs that something isn't quite right. Maybe an operator notices a strange noise, a burning smell, or unusual vibrations. These anomalies might not shut everything down immediately, but they often point to an issue waiting to become more serious. Catching these early signs and acting on them prevents bigger failures down the road. The first step in troubleshooting is to clearly define the problem. This might sound obvious, but it's where many people make mistakes. If the problem is described vaguely, the solution will also be vague. Instead of saying, "The system isn't working," we should specify, for example, "The server is not connecting to the network." That level of clarity makes it much easier to trace the source of the issue and narrow down possible causes. Once the problem is defined, the next step is to gather as much relevant information as possible. This could include reviewing system logs, checking maintenance records, or talking to the people who were operating the equipment when the issue appeared. Even small details from users can be valuable clues. In many workplaces, we also rely on tools like a CMMS, that's a computerized maintenance management system. It's a software tool that keeps a history of past issues, repairs, and maintenance activities. Having this organized record can make troubleshooting much faster because we're not starting from scratch every time. Patterns start to emerge. For example, you might compare current performance with historical data, or eliminate possible causes one by one. The key here is to be methodical. Instead of jumping to conclusions, we take a logical approach, asking questions like, has this problem happened before? What conditions were present when it occurred? Is there a consistent trigger? This step helps us focus on the root cause rather than just symptoms. Once we've narrowed things down, it's time to propose a solution. But rather than rushing into the most complex fix, it's usually best to start simple. Try the least intrusive option first and see if it resolves the issue. Importantly, we don't just assume the fix will work, we test it. If possible, we test on a small scale, or in a controlled way before applying the solution fully. This way, if it doesn't work, we haven't created a bigger problem. When a solution has been tested and proven effective, the next step is to implement it fully. At this stage, communication and documentation are crucial. Everyone involved needs to understand what was done, and the solution should be recorded for future reference. This documentation becomes a valuable resource the next time a similar issue arises. It saves time, prevents repeated mistakes, and helps new team members learn from past experience. So, if we step back and look at the process as a whole, troubleshooting follows a clear sequence: define the problem, gather information, analyze the data, propose and test a solution, and finally implement and record it. This structured approach makes troubleshooting faster, more reliable, and less stressful, whether you're dealing with machines, networks, or day-to-day processes. To make this more concrete, let's look at a common type of issue: physical connectivity problems. These are especially common in IT and networking. Sometimes, the cause is as simple as a loose or improperly connected cable. Other times, a router or switch port may be faulty, or there may be too much traffic overwhelming a link. In some cases, the problem lies in configuration settings at the physical layer, such as mismatched speeds or incompatible hardware. The lesson here is that even when issues seem complex, the solution often starts with checking the basics first before diving into advanced technical fixes. In the end, troubleshooting is as much about mindset as it is about technical skill. The best troubleshooters are systematic, patient, and curious. They don't just patch the surface problem, they dig deeper to understand why it happened and how to prevent it from happening again. By applying these principles, we can turn what might feel like a crisis into a structured, manageable process, keeping operations smooth and avoiding costly downtime. So to wrap things up, troubleshooting is really about having a clear, step-by-step approach. We start by defining the problem, then we gather all the information we can, analyze it carefully, propose and test possible solutions, and finally implement the fix while documenting what we've learned. What might seem like just fixing something is actually a skill, and when done systematically, it saves time, reduces stress, and prevents costly downtime. Whether you're dealing with a machine that stopped working, or just small anomalies like strange noises or unexpected behavior, the same principles apply. The best troubleshooters aren't just people who know how to repair things. They're people who think methodically, stay calm under pressure, and use every problem as a learning opportunity. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more practical guides like this. And in the comments below, share one of your own troubleshooting experiences. It might just help someone else who's facing the